we're talking about how to solve really big, complex problems, the ones with tons of moving parts. And we're going to see how code makes it not just possible, but actually kind of elegant. So let's dive in and see how a simple grid of numbers can tame even the most chaotic problems out there.
I mean, really think about it for a second. How on earth does a city manage traffic with thousands of cars all going in different directions? Or how do engineers make sure a massive bridge is actually going to be stable? Heck, how does a company even begin to balance its budget across dozens of different departments? All of these are just problems with a whole bunch of interconnected unknowns. It sounds impossibly complicated, right? Well, it turns out there's a really powerful way to cut through all that chaos.
So, what is ERO, elementary row operations? It is a basic operation applied to the rows of a matrix. There are three types of operations: swap rows, multiply a row by a non-zero constant, add or subtract a multiple of one row to another. The purpose is to simplify the matrix to solve systems of linear equations efficiently. Next is Gaussian elimination. It is a systematic method to transform a matrix into row echelon form. It allows step-by-step determination of variable values. It also can be extended to reduce row echelon form for unique solutions. This is the example of row echelon form and reduced row echelon form. Lastly, matrix inverse method. It uses the inverse of a square matrix to solve linear equations. It only works if the matrix is invertible, which is non-singular. The solution formula is x equal to matrix A inverse times with matrix B, where A is the coefficient matrix and B is the constant vector. And this is the solution for a matrix inverse 2 by 2 and 3 by 3. Importance of solving linear equations using programming. There are 5 importance. First is speed, because solving large systems manually is very time consuming. Next, it reduces human calculation errors as per the accuracy. And it can handle complex and large systems with many variables. For the automation, repeated calculations can be done automatically. Programming languages we use is Java, but you also can use Python, MATLAB, and others provide built-in functions for matrices and operations.
Elementary row operations, step-by-step, and Java implementation. Step 1. Change the linear equation given to the augmented matrix form. Step 2. Change 2 in column 1, row 1 to 1 using R1 divided by 2. Step 3. Change 1 in column 1, row 2 to 0 using negative 1 multiply R1 plus R2. Step 4. Change 5 over 2 in column 2, row 2 to 1 using R2 divided by 5 over 2. Step 5. Change 1 over 2 in column 2, row 2 to 0 using negative 1 over 2 multiply R2 plus R1. The final answer is achieved when column 1 and column 2 are converted into an identity matrix. Java implementation by using JGraphs. Represent the system as a matrix. The system of linear equation is stored in a 2 by 3 augmented matrix. Perform row operations programmatically. Divide a row by a number, converts the first element of row 1 to 1. Add or subtract multiples of a row, eliminates the first column in row 2. Normalize another row, makes the leading element of row 2 equal to 1. Eliminates other entries, removes the second column element in row 1. Extract the solution from the matrix. After all operations, the last column stores the solution. The final answer as the output outcome, x equal to 9/5, y equal to 7/5. End of ERO method.
Hello everyone, my name is Putri Yana Sorfina, and today I will teach you how to solve a system of linear equation using the matrix inverse method. But before that, what is matrix inverse? A matrix inverse is a matrix that refers the effect of matrix multiplication. For square matrix A, its inverse is denoted as A inverse. When A is multiplied by its inverse, the result is the identity matrix A times A inverse equal to I. The matrix inverse is used to solve system of linear equation in the form AX equal to B. But take note, not all matrices have an inverse, only invertible matrices do. Next, the importance of matrix inverse. It reduces manual calculation errors, efficient for programming and automation, also used in engineering, computer science, and data analysis. Let's get started with a step-by-step linear algebra solution. First, we are given a system of two linear equations, which is 2x plus y equal to 5 and x plus 3y equal to 6. When doing matrix inverse, you guys should remember this. AX equal to B. So, as we know, for the two linear equations, 1 and 2, we have to convert it into AX equal to B, where x is 2, 1, 1, 3, x is xy, and B is 5, 6. So, this is the matrix form of the given system of linear equations. So, let's move on to the next step, which is determinant. The formula is AD minus BC, so just take it from the matrix A and we got 5. Since it is not 0, the inverse of matrix A exists. Next, we have to insert everything into inverse matrix formula. So you guys have to remember this formula. Don't forget to add negative to the B and C. Next, substitute all the input, and also this formula is only exists if determinant is not 0. Next, just insert all the value in the formula of x equal to A inverse B and done it until we get x and y. Next is Java implementation. For this question, so the first one is the Java class and the main method. Next, the variable represents the coefficient of matrix A taken directly from the equations. Next, store the constants from the right hand side of the equation in vector B. The next error, the fourth error, determinant of matrix A using the formula AD minus BC. Next, determinant is 0. The inverse matrix does not exist, so the program stops. Next, compute each element of the inverse matrix using the standard inverse formula for a 2x2 matrix. The next box on the right side is bring the final solution for x and y. And the last one is substituting the value of x and y back to the original equation. So we got the solution x equal to 1.8 and y equal to 1.4, just the same as we did before. So I think that is all from me. Thank you.
In this part, we will solve a system of linear equations using Gaussian elimination.
First, we solve the system using the normal mathematical method. Convert the equation into an augmented matrix. Row 1 contains 2, 1 and 5. Row 2 contains 1, 3 and 6. To make the first pivot equals to 1, divide row 1 by 2. The matrix becomes row 1 contains 1, 1 over 2 and 5 over 2. Row 2 contains 1, 3 and 6. Next, eliminate the x term in row 2. Row 2 equals row 2 minus row 1. After simplification, the matrix becomes row 1 contains 1, 1 over 2 and 5 over 2. Row 2 contains 0, 5 over 2 and 7 over 2. Now divide row 2 by 5 over 2 to make the second pivot equal to 1. The matrix becomes row 1 contains 1, 1 over 2 and 5 over 2. Row 2 contains 0, 1 and 7 over 5. Next, eliminate the y term in row 1 by subtracting 1 over 2 times row 2 from row 1. The final matrix is row 1 contains 1, 0 and 9 over 5. Row 2 contains 0, 1 and 7 over 5. From the final matrix, the solution is x equals 1.8, y equals 1.4. Now, we verify the solutions using Java programming and JGraphs. In Java, we begin by defining a class and a main method. Inside the main method, we create a two-dimensional array to represent the augmented matrix of the system. The first row of the array stores the coefficient and constant from the first equation. The second row of the array stores the coefficient and constant from the second equation. Next, we apply Gaussian elimination step by step using loops. First, row 1 is divided by 2 so that the first pivot becomes 1. This operation is done using a loop that divides each value in row 1 by 2. Next, the x term in row 2 is eliminated. This is done by subtracting row 1 from row 2 using another loop. After that, row 2 is divided by its pivot value, which is 5 over 2, so that the second pivot becomes 1. Next, the y term in row 1 is eliminated by subtracting 1 over 2 times row 2 from row 1. After completing all row operation, the matrix reaches reduced row echelon form. After running the program in JGraphs, the output obtained is x equals 1.8, y equals 1.4. The Java solution matches the mathematical solution exactly.
Now, we will learn what are the limitations for ERO. First, it requires many arithmetic steps when solving systems with many variables. Having repeated row operations can cause accumulated calculation errors as well. No matter it is a large or small numbers, it will reduce the numerical accuracy. Also, manual application becomes quite inefficient for large systems. Limitations for matrix inverse method. It is only applicable to square, non-singular matrices. If the determinant is 0, the matrix inverse does not exist. When computing the inverse, it is inefficient for large matrices. Also, the ill-conditioned matrices can amplify numerical errors. Limitations of Gaussian elimination. Round-off errors may occur when using floating point arithmetic. A very small or zero pivot elements can lead to numerical instability. Pivoting techniques also are needed to improve accuracy. Do you know that computational cost increases as the size of the system increases? Please take note, despite these limitations, all these three methods remain fundamental in the syllabus and are widely used as the basis for numerical and computational approaches. Using on comparison of methods, as for the accuracy, all methods does yield the same solution when applied correctly. As for flexibility, ERO and Gaussian elimination work for both small and large systems. Meanwhile, matrix inverse only works for square and invertible matrices. And efficiency, Gaussian elimination is generally faster for manual computation of larger systems, and programming makes all methods efficient regardless of size, which now we are focusing on Java. Summary for each methods learned. Gaussian elimination is considered as the most practical overall because it is balanced in efficiency, accuracy, and ease of programming implementation. Meanwhile, ERO is flexible for stepwise simplification and matrix inverse is formula-based, but it is very limited in application. As for the credits, I, Swarupa, prepared the introduction and conclusion video. Meanwhile, Farzana developed the ERO code and the video. Putri, she did the matrix inverse code, and Fitriyani, she did the Gaussian elimination code. In conclusion, we explored elementary row operations, ERO, Gaussian elimination, and matrix inverse method. All these three methods produce the same solution when applied correctly. Using Java programming makes solving faster, more accurate, and able to handle large systems. And we conclude that Gaussian elimination is the best method as it is the most practical overall due to its balance of efficiency and accuracy. That's the end. Thank you.